All right, now these proofs are, believe it or not, much easier than the ones that I had been giving you. Much easier and much faster, many less steps. So sine, I have sine of two angles being added together here. So I go to my little formula sheet, and that's sine of pi over 2 cosine of theta plus cosine of pi over 2 sine of theta. I need to show that that is cosine. All right, well, sine of pi over 2, my sine curve goes like this. What's happening at pi over 2? It's 1 times cosine of theta. So what's that? Cosine of theta. All right, over here, I have cosine of pi over 2. That's looking at this picture. What's happening at pi over 2? It's 0. So I get plus 0 times sine of theta. What's that?
0.
0. What's cosine plus 0? Which is what I wanted. Yeah, these are much faster than the other ones were. Right, and they usually rely on the wavy graphs. All right, this one's actually going to be really similar. So I have sine of pi minus theta. So I have sine subtracting two angles. So this one's going to go sine of pi cosine of theta minus cosine of pi sine of theta. All right, so we take a look at sine of pi. What's happening at pi? Nope. 0. So it's 0 times cosine of theta. What's that? 0. All right, and then I have minus, right, cosine at pi. What's happening there? Negative 1 times sine. So I have 0 minus a negative 1 times sine, so I'm going to get positive, or plus sine, because I add the opposite. 0 plus sine is sine, so I get what I wanted here. Not too bad. All right. I kind of like this one. You guys may or may not. Probably not. All right, but this one's a little tricky. All right, now, if I had to decide which one was more complicated, it's kind of a toss-up because one involves something that I can turn into sines and cosines, and the other one involves these new formulas that we just talked about last week. I'm going to go with the left-hand side. So let's take a look at these. So if I have sine of two angles plus each other, and I change these rather than using alphas and betas, those are hard to write. So I just made them x's and y's. So I've got sine of x cosine of y plus cosine of x sine of y over, then when I have two angles subtracting each other, sine of x cosine of y minus cosine of x sine of y. All right, and I know that looks a far way away from where I need it to be.
It's exactly where you need.
Sort of. What's good about this? Well, my signs are in the right place. I've got a term plus a term, and then I have a term minus a term. And that's what I have here. So tell me, what do I need to get rid of here?
The signs are not the same.
Well, just pick one of these terms and figure out how to turn it into the other one. So let's look at this one.
That one you need to
and
get
this
rid
one.
of the cosine of y. I mean
Okay, so cosine of y has to go. So I would have to like divide or multiply this by a cosine of y, 1 over, so that I can get it in the denominator so that they cancel. And then sine of x over what will get me a tangent of x. So I also need a cosine of x. But if I do that in the top, I have to do that in the bottom. Now just by evaluating it at that one spot in my problem, it fixes everything. Because now when I distribute this through each one, I'm going to get sine of x, cosine of y over cosine of x, cosine of y, plus cosine of x sine of y over cosine of x, cosine of y. All over. Down here, I'm going to get sine of x cosine of y all over cosine x cosine y minus cosine x sine y all over cosine x cosine y. Right? So simplifying time, lots of things to simplify. Cosine y, that's 1. And then I get sine of x over cosine of x, tangent of x, here I get cosine x canceling, and then I have sine of y over cosine of y, that is tangent of y, and I'm adding those, over, down here, cosine y, tangent of x, minus, these guys cancel, tangent of y. So, actually, not too bad.
Just thought.
All right, what makes this one kind of annoying is we don't have a cotangent formula. So we have to rely on the 1 over tangent version of this thing. So this is 1 over tangent of x plus y. All right, so I'm just going to deal with the tangent of x plus y for now, and then when I'm all said and done, I'm going to put it over or under a 1. Okay, so when I put it into my little formula here, I'm going to have 1 over tangent x plus tangent y all over 1 minus tangent x tangent y. Okay. Well, if I multiply by the reciprocal, I'm going to get 1 minus tangent x tangent y all over tangent x plus tangent y. Okay, now that's close to where I need it to be. What's wrong with it?
Sines?
It's tangents and cotangent.
Yeah, sine's in the top, that's backwards, right? Because we need it to be a tangent x.
What could you do? Multiply by negative 1.
Well, what do I want to multiply by? Somehow I have to get cotangents in there instead of tangents.
1 over tangent.
Let's see. 1 over tangent, well, tangent of what? X or y? Both. Agreed. Both. So if I multiply the top by 1 over tangent x cotangent y, I'm sorry, tangent x tangent y, then I have to do the same thing in the bottom. Because that's going to give me the right thing here, because if I have 1 over those two things, that's really cotangent of x and cotangent of y, just like I have up here.
And as long as there's no other cotangent, it's going to be okay.
Mm-hmm. So this is actually going to work out pretty nice for us. So I'm going to get 1 over a tangent x tangent y down here in the bottom. So when I do that, I'm going to get what I want, 1 over tangent x tangent y minus tangent x tangent y over tangent x tangent y. All of that over. Now when I have to distribute through both of these terms as well, and get tangent x over tangent x tangent y plus tangent y over tangent x tangent y. Cancel time. So what is this really?
That's cotangent of x times cotangent of y.
Okay. And then what's this really?
1.
And then these cancel, so I get 1 over tangent of y. It's cotangent of y. And then these cancel, so I get 1 over tangent of x. So I'm going to get cotangent of x. Yeah, we were supposed to get that up here.
Double error.
Yeah. Bringing it back.
Like.
I missed. Fortunately, it was a heat seeker. So, okay. All right, so on this one, we ended up with every trig function we hate in the same problem. Secants, cosecants, and cotangents. So I would start this one out by, we don't even have a formula for secant here, so 1 over cosine of x plus y, and deal with that for now. So when we plug that in, we're going to get 1 over cosine of two things being added, cosine of x, cosine of y, minus sine of x, sine of y. All right, well, let's do like we were doing before and kind of compare this to what I have up here and then figure out what I need to get. And the thing that stands out to me is somehow I need this part here to be a 1. So doesn't that mean that I need to divide by it?
Yep.
Or multiply by its reciprocal? Same thing in the top then, so that I'm actually multiplying this by a fancy 1. So when I distribute that through here, I'm going to get, in the top, I'm going to have 1 over sine of x, sine of y. That was an easy one. Over, down here when I distribute, I'm going to get cosine x, cosine y, over sine x, sine y,
It's 1 over
minus sine x, sine y, over sine x, sine y.
It's 1 over sine x, sine y, cosecant x.
Yep.
Alright, we got the top covered.
And this is 1, just like we wanted it to be. Over here I've got cosine of x over sine of x, cotangent, because it's the flipped over version. Same thing here, cotangent, but of y. And that's in the bottom. And then in the top I have 1 over sine and 1 over sine.
Cosecant x, cosecant y.
Cosecant x, cosecant y,
Look at that.
which is really what I wanted up here.
Right on the money. In the arrow.
Mental picture I took that time.
Beautiful.
Plus I ran out of heat seeker. They're expensive.
Where's the shirt?
Okay, this one's a little rough. I've got 2 of my new formulas to write down this time. So I have the sine of 2 angles being subtracted, so that's going to be sine x cosine y minus cosine x sine y. And I need to multiply that by sine of 2 angles being added. Sine x cosine y plus cosine x sine y. So what am I stuck with doing here? No one wants to do this. Yikes. Alright, so I have to FOIL this. So I'm multiplying this one by this. What do you notice about those two terms? So I'm going to get sine squared x cosine squared y. Okay, and then when I multiply this one by that one,
That's ugly minus an ugly size.
right, so I end up getting all of them together, a sine x, a cosine x, a sine y, and a cosine y, positive. But then when I do this one times this, I'm going to get the negative version of that, so they cancel.
And then we have
So you don't even have to worry about
cosine
that.
squared x sine squared.
Right. So all I have to worry about is doing this one, so I'm going to get a minus. They're the same, so cosine squared x, sine squared y.
And that equals sine squared x.
We're trying to get rid of the cosine in this situation.
I want to keep those signs. I like those. All right, so this is what happens. What can I put in for each one of these things?
1.
Not 1.
1 minus sine squared.
So I'm going to get 1 minus sine squared of y, because it's a y one. And then over here I'm going to get minus, so this is going to be 1 minus sine squared of x times my sine squared of y. Distribute. Sine squared of x minus sine squared of x sine squared of y, which at this moment in time it doesn't look like it's much better, does it? But this, if I were to bring this out in front here, because multiplication is commutative, that's technically a negative sine squared that I can distribute through, correct? Follow that? Why it's going to be negative? So I'm going to get a negative sine squared times 1, which is a negative sine squared of y, and then a negative sine squared of y times this, which will actually get me a positive sine squared of x sine squared of y.
That looks like some ugly cancer.
Why is it sine squared x sine squared y? Shouldn't it be sine to the 4th x minus sine to the 4th y?
They're not the same. It's not sine squared of the x times sine squared of x.
Oh, I see.
Sine squared of x times sine squared
You're
of
just-
y.
you're just
They're
doing-
2 different pieces. They look really similar, and you have to fight that urge. And that's kind of what makes these a little harder. You got to remember that sine of x and sine of y are not the same.
Gotcha.
All right, so the good news is this cancels with that, so now I've got sine squared of x minus sine squared of y, which is what I wanted way Actually, not way up here, but right there.
Beautiful. Is that it for today?
Yep. So kind of tough, that one. I think that one was the hardest out of all of them, especially because of this 1 minus sine squared thing we had to do. But all the other ones, pretty straightforward. I kind of like them because you can look at where, you do what you know you need to do by using the formula, and then you kind of compare that to where you need to go and figure out what you have to do to this side to get that. And it's not too bad.